Hi guys, good evening you all. So how are you all?
Good evening, sir. We are fine, sir.
Okay, so till all join, we'll chit chat some bit. Okay, so how was the question paper? That all those 20 questions. Tell me, you all three have sent me the answers. So how was the question papers? Like I know it was not same to the level of like AFET. It is bit harder than that. So how was the questions?
Yes, sir. The question is basically, uh, I mostly use elimination method, sir.
Okay. See, actually in most of the UPSC papers, questions will be same lines only. Only some questions will be like static questions, means they'll be asking a straight way. Means this place is located in which place, then some kind of like so in that in some questions they'll be asking some easy question. They will asking only some particular questions. Nowadays what they are doing, now competitions are increasing. So because of that, what they are doing, they are increasing the difficulty level of the paper. So they are giving most of the questions in the statement based questions. So they'll be asking to select you like A, B, then A, B, C, like they'll be asking. So you must be prepared for that one also. So we'll practice everything. See, actually, since I am teaching also, for that I have to prepare PPT also. So little bit late in giving all the questions. After few days, I will give you the question papers daily, like one papers, so that from the geography only, so that you get familiar to all the questions and you will give me the answers. After that, we'll put all those questions and answers on the YouTube channel. So from there you can see the answers also. And if I have time, I'll check your answers and I'll guide you where was the issues, everything. So okay, if you have numbers of all other persons, please ask them to join fast. Only 3 of you are here. Okay, one more person has joined. VV, what's your full name? VV, what's your full name? Are you there? First time you are joining the class. What's your full name? Okay, guys. So with 3 students only we'll start our class. So today we are going to study about climatology. We had finished all those geomorphology part. So today we'll start with climatology. Okay, see, in that climatology part, we'll see everything about the atmosphere, structure of atmosphere, then composition of atmosphere. Then we'll be seeing the pressure belts. We'll be seeing winds. Then we'll be seeing about all other parts like desert, how desert is formed, then how climates changes are taking place. All those everything we'll see in this part. So okay, so we'll start our class with the structure and composition of atmosphere. Wait a minute, guys. This issue is pen. Okay, so here we'll study about the structure and composition of atmosphere. So here in this, first we'll see about how the origin of atmosphere took place. Okay, how oxygen evolved on the surface of Earth. All those things we'll see in this class. So in the origin of atmosphere, what happened when we had the Big Bang? When we had the Big Bang, that time what happened? There was a nebula, a single nebula that broke into different parts. Okay, that huge nebula broke into different parts, and that rock got thrown at every places. Then all those rocks broke into smaller parts. So there we had found the Earth. So there was the occurrence of the Earth planet. So in that, see, only on the surface of Earth, why this life is possible. So that is because of atmosphere. If there was no atmosphere, then there would have been no life on the Earth. So how this atmosphere took place? So see, when after the Big Bang theory, all those broken parts, then Earth was now in a solid state, but the inner part was in a, like you can say, in a molten state. Okay, so inner part was so hot. Inside we have the radioactive materials. In the inner part we have radioactive materials. So there was chemical reaction was going inside this one. So what what happened? Due to this thermal difference inside the earth, we had, see, inside the earth we had the presence of hydrogen and helium. Okay, in the 4.5 billion years ago, when we had the formation of earth, so we had this hydrogen and helium. So after some times, what happened? This hydrogen and helium, they escape from this part because of high amount of heat inside the earth. They escape from inside the earth. So after it, when they escaped, they went and they mixed with the outer parts. Okay, not in the earth, outer parts, like you can say in the atmosphere, where we have the atmosphere, we have till 200 kilometer. So like you can say it in space. Okay, then after that, when those went and mixed, then in that what happened? There we had the formation of cloud. So in atmosphere we have the formation of cloud. Then after formation of cloud, raining happened. Then after it, in some phases we had the occurrence of volcanoes. There was, due to plate movement, we had the occurrence of volcanoes. So when volcanoes took place, that time large amount of gases will come out from this. Like you can say it as the sulfur will come, sulfur, then carbon dioxide, carbon monoxide, sulfur will come, then carbon dioxide, carbon monoxide. Then we have other amounts of gases. So they, because of this hydrogen helium, they escape from this gravity. They escape from the Earth's gravity, and this, when the volcanoes took place, so we had the sulfur, carbon dioxide, carbon monoxide, all this. Then we also had the hydrogen. So they went and mixed in the atmosphere. Then after it, rain started. See, in the starting classes we had studied that time we did not have the presence of oxygen. Okay, how oxygen came? Oxygen came that when we had the unicellular bacteria, that you can say the algae. So in the ocean, so after that what happened? They started doing photosynthesis. Then due to the photosynthesis, we had the oxygen. Because of photosynthesis, we had the oxygen presence in the atmosphere. So when they started doing photosynthesis, they started exhaling the oxygen, and they started inhaling the carbon dioxide. So after that only oxygen got evolved on the atmosphere of the earth. So this was the process. So see here, like other planets and moons in our solar system have atmosphere, but none of could support life as we know it. Why they could not support? Because they did not have the presence of oxygen. Okay, so they are too dense or not dense enough. So, and none of them has much oxygen. So see it, the precious gas that we earth animals need every minute. So how we got oxygen? So that we are studying. Hydrogen and helium got escaped. Okay, then after that what happened? During the cooling of earth, gases and water vapor were released from the interior solid earth. Okay, hydrogen and helium got escaped. Then after that, when cooling started, we had the gases and water vapor, they were released from the interior of the earth. So what happened? There started the evolution of the present atmosphere. So this process is known as the degassing. So when we had the degassing, that time also we did not have the presence of oxygen. Okay, other all elements were present, like CO2. That time CO2 was in highest amount. So that time we had the presence of CO2. So when degassing happened, we had the gases consisted of hydrogen, water, methane, carbon dioxide. Okay, so when the degassing took place, that time we had the hydrogen, water vapor, methane, and carbon dioxide. So remember that in the origin of atmosphere, we had the process of degassing. Okay, this was one process. Then one more process is that we had the, when we had the presence of carbon dioxide. Okay, then inside the ocean we had algae type. Okay, then they started doing the photosynthesis. So when they started doing the photosynthesis, so they were releasing the oxygen and they were inhaling the carbon dioxide. So in this way, that led to the evolution of oxygen in the atmosphere of our earth. So see it, So our Earth was formed 4.5 billion years ago. So prior to 3.5 years ago, the atmosphere probably consisted of carbon dioxide, carbon monoxide, water, nitrogen, and hydrogen. So this all we saw in the previous slide. Then after that, what happened? Hydrosphere was formed when we had the Tethys Sea. When that apart, Pangea broke into different. When Pangea broke into different parts, then we have the formation of Tethys Sea. Then other parts we had the formation of Angara land and Gondwana land. So in that Tethys Sea, so and we had a big ocean in ancient days, Panthalassa. So that also started expanding. So there we had the hydrosphere. So that hydrosphere formed 4 billion years ago from the condensation of water vapor, then oceans of water, then in that oceans of water sedimentation occurred. So the most important feature of the ancient environment was the absence of. So in that time also there was absence of oxygen. So here we say about that particular unicellular bacteria. So after that unicellular bacteria came, then after that when they started that blue-green algae. So what happened? That aquatic organism, they started using energy from the sun. So they split molecules of H2O and CO2. So after that, they combine the organic compounds and then molecular oxygen evolved. So in that what happened? The remaining oxygen accumulated in the atmosphere, so touching of a massive ecological disaster with respect to early existing anaerobic organism. So this unicellular was anaerobic. Okay. So without oxygen they were making their food. So after that photosynthesis there was evolution of oxygen. So this was when oxygen came, then we had finally the evolution of our earth. So see here in this diagram you can see inside this we have the heat. Okay, then we have the radioactive material. See here inside the earth we have that radioactive material. Then that fusion and fission occurring that took place inside the earth. So because of that, hydrogen and helium got escaped. Okay, then they went upwards in the space side and they mixed. Okay, then when volcanoes occurred, then volcanoes, all those gases released, they went and they mixed with the atmosphere and they formed the cloud. Then when they formed the cloud, then we had the rainfall. So after that rainfall, we had the when we had the volcanoes evolution, when we had the volcanic eruption and that hydrogen helium escape. So during that time we had the CO2, water vapor, methane, ammonia. So when this cloud went and mixed up, so there we had the water. So there what happened? Due to after that condensation, that precipitation, so there was rain on the earth. So in this way, after it, in this way, and finally because of when there was rain, so we had the formation of water, oceanic waters. So after that, when we had the oceanic water, then there we found there we had the blue-green algae. Then after that, when we had the blue-green algae, they started doing anaerobic respiration and they started doing the photosynthesis part. So when they started doing the photosynthesis part, so after that only there was evolution of oxygen. So after that there was evolution of oxygen. Then finally that oxygen they went and mixed in atmosphere. Then finally we had the type of atmosphere that we have in the present days now. So that is about the atmosphere. So in that all those everything are explained in the like in atmosphere phase 1 we had the hydrogen and helium. So they were warm and they escaped from the earth interior. Then in phase 2 what happened? That volcanoes erupted. So when that volcanoes erupted, we had the hydrogen, carbon dioxide, ammonia, all those gases we had. So after it we had the formation of cloud and then we had the rain and then we had water body. Then after that there was a blue-green algae. They started doing the photosynthesis part. Then we had the evolution of oxygen. So in part 3 plants and animals thrive in balance. Plants take in carbon dioxide and give off oxygen. So after that we have the finally formation of atmosphere, which is present now. So this is all about the origin of atmosphere. Okay. So when we have the origin of atmosphere, so now we should know that what is atmosphere. Atmosphere means what? Atmosphere is a envelope of gases. Atmosphere is an envelope of gases, or that envelope that can look like a, you can say it as a blanket, deep blanket of gases. Okay, that they're extending thousands of kilometers above its surface. So that gaseous cover of the earth is known as the atmosphere. So like we have the, see, like land we have the lithosphere, then water hydrosphere. So similarly in that also atmosphere also the integral part of the earth. And this atmosphere, all this lithosphere, hydrosphere, all those are held by the gravitational influence of the earth. So similarly in that way atmosphere is also held by the gravitational pull of the earth. Okay, now we see about the structure of atmosphere. So see, when we had the origin of atmosphere, so in that some layers, that particular specific process was going on. So that specific process we divided that into the layers type. So totally we have the 5 layers of atmosphere. So arrangement of these 5 layers of atmosphere is known as the structure. So that those layers can be studied. Like first we have the, see, suppose if this is our earth, this is our space part. Okay, then here we have the, now as we go up we enter into atmosphere. So from here, from 0 to 18 kilometer, in some book there will be 16 kilometer or 18 kilometer. So sorry, 0 not 0, 8 to 18 or 16 kilometers we have the troposphere. Okay, so see here in some part what we can say, totally here we have the 5 layers. Okay, but whereas in some part inside the thermosphere we have the presence of ionosphere. So in some book it might be given that there are 6 layers of atmosphere. Okay, but scientifically it is totally 5 only. Inside the thermosphere we have the ionosphere. Okay, so in that first layer of the atmosphere array, that is troposphere. So first layer we have troposphere, then we have stratosphere, then we have mesosphere, then we have thermosphere, and then finally we have our exosphere. So all these they are arranged based on, all these are they are arranged on based on the different processes occurring in those parts. Okay, so first we'll see that atmosphere, they can be divided into 2 types. Okay, they can be divided into different types. One is based on the chemical composition. Okay, and another is the based on the temperature. So first we'll see that based on chemical composition. So based on chemical composition we have the, see, all those layers are arranged in the same type. Okay, in that chemical composition also, but based on chemical composition we have one homosphere and other one is heterosphere. So similarly in that what is happening, all those layers, okay, there are 3 layers in the homosphere. They are tropo, strato, and then we have the mesosphere. And outer layers of the earth, so that they are thermospheres and the exosphere, they are the part of heterosphere. So they are divided based on the chemical composition. So on the chemical composition we have these 2 types, that is heterosphere and homosphere. So chemical composition what means? Homosphere means, you would have studied in science, homosphere they would have same composition. So here in this chemical composition, why that this meso, strato and tropo are known as the are the part of homosphere because they have the same composition of gases. Okay, that's why they are the homosphere, and other parts here composition we have the in the different amounts. So that is the heterosphere. Then in thermosphere itself, in the thermosphere we have ionosphere. So don't get confused between that what layer will come after the mesosphere. So just remember that in thermosphere we have the ionosphere. So here what is this? If options come for arrangement of the layers of the atmosphere, so you must know that tropo, strato, then we have meso. Okay, tropo, then we have strato, then we have meso. So after that, in the options, if it is given that ionosphere, then mark ionosphere, or if it is given that thermosphere, then mark thermosphere. Okay, and if both are given iono and thermosphere, then first mark ionosphere, then mark thermosphere. Okay, then at the end we have that outer layer of the earth, that is exosphere. So now this is based on the chemical composition. So based on the temperature also, our layers of the earth are arranged. So layers of the earth, they are arranged in the same manner. Okay, there is no change. So now see, most of the gases, most of all those parts, okay, most of the occurrence on the earth we have in the troposphere. If you take it like 90% of occurrence happens on the earth, that is presence in troposphere. And if you go up to mesosphere, then totally like out of 100%, 99.99% all those occurrence happens in these three layers. So remember this one. Then see here, you must know this diagram. So see, first we have tropo, okay, then after it what happens, suppose see, this is troposphere. So here what happens, now why they are showing like 16 kilometer or 18 kilometer, in some book it might be mentioned. So after troposphere, there is a starting of stratosphere. So before that what happens, there is a pause of troposphere. So that pause is known as the tropopause. So okay, so after troposphere we have tropopause, then we have the starting of stratosphere. Then after a stratosphere we have a pause. So see here, now when we on the based all these layers we are arranging on the based on the temperature distribution. So when we are arranging on the based on temperature distribution, so there what happens, see here, now according to height we have given in this vertical, then horizontal we have taken it as according to temperature. Okay, so when we are on the earth, there it is feeling like temperature like 30 degree light temperature. So when we are in the ground of the earth, so there you can take it at like 30 degree also you can take, or 20 degree. So from here this layer start, and we know that troposphere extends up to 16 kilometer or 18 kilometers. Okay, so here it will go up to like 18 kilometer and 18. Then after that we have the starting of tropopause. Why tropopause? Because after that, see, after that what happens, see, in this troposphere we have one part, that is as we go up, so at the each 1 kilometer, at the each 1 kilometer 6.5 degree Celsius temperature decreases. Okay, so see, if you see this marking point, why it has come to minus 40 degree? Okay, so why it has come? So here like we have started, so at the each 1 kilometer temperature is decreasing. So as you go at this up, like here nearby 18 kilometers, so here temperature decrease. So after this what happened in the tropopause area, that particular, this is known as the normal lapse rate. Okay, this is known as the normal lapse rate. So here what happens in the lapse rate. So here what happens in the troposphere part, after when the tropopause starts, so there that temperature becomes normal. Then after it what happens, Now when we are entering the stratosphere, then in the stratosphere part we have the temperature inversion part. Okay, so what is this temperature inversion? Now see, our layer is going like, so here temperature is decreasing, but again in the stratosphere when it's going, that there also is a decrease, but here what is happening? Here it is increasing. Okay, why it is increasing, that we will study in the later part. In this video we will see. So here temperature is increasing. Okay, so that particular where the temperature is increasing, so that is another temperature inversion. So okay, then again as we go in the mesosphere, so again there will be the normal lapse rate. So this mesosphere is known as the coldest layer of the atmosphere. Okay, remember that one. Then again when we go up here, again temperature increasing because of presence of ions in this layer. Then after that exosphere means there will be no presence of oxygen or anything. So there again after that we have the like ultraviolet rays are coming, so their temperature will be high only in exosphere. So in the troposphere layer part, so see all these layers how they are arranged according to height. So you must remember the height of all these parts. So troposphere is 8 to 18 kilometers. Troposphere is 8 to 18 kilometers. Then we have the stratosphere, that is 18 kilometer to 50 kilometer. Then mesosphere is 50 to 80 kilometer. Okay, then after that start the thermosphere 80 to 700 kilometer. Then exosphere 700 to 10,000 kilometer. So here in this, what is happening? Here we have the presence of Karman line. So when we cross the Karman line, so it is known that we are going into the space. Okay, so when a human being crosses this Karman line, they are known as the astronauts. So okay, so this is all about the arrangement of layers of atmosphere. So now first we'll see about the troposphere. So in the troposphere, we have the normal lapse rate. So in troposphere we have normal lapse rate, that is at each 1 kilometer, at which 1 kilometer 6.5 degrees Celsius is decreasing. Okay, that is known as the normal lapse rate. And when we have the increasing, so that is known as the temperature inversion. That we will see in the stratosphere part. Okay, so here what is happening? See, where we have the, when we see about the wind moves from, that in later stage also we will study that wind moves from high pressure to low pressure. Okay, wind movement is there from high pressure to low pressure. Okay, so here what we have, at the equator we have the maximum height 16 to 8 kilometer, and as you go towards the pole, so pole side we have only 6 to 8 kilometer. Okay, so at the equator we have the, so here what is happening? Here you must remember that at the pole, this is a cold days. Okay, at the pole you know means it will be in winter, but here what is happening? Now when this temperature inversion is happening, sorry, normal lapse rate is happening. So here if it is 8 kilometers, so you can multiply your temperature 8 into 6.5. Okay, so 8 into 6.5 when you multiply, you will be getting here temperature like minus 45 degree. Sorry, 42. So like in average temperature you can say that you will be getting 45 degrees. So that is average temperature, because temperature will not same everywhere. But where here height we have, so here if you calculate the height according to the normal lapse rate, so here we will be having that average temperature as like minus 65 degree Celsius. Okay, so that you must know. So here what is happening? Here air, since we have the high pressure this side, here we will be having the temperature. Now this earth sun is directly falling over at the equator. So here we have the high temperature high. So when we have the like temperature be high, so what will happen then? That surface of the earth will be warm. So there what will happen? wind will ascend, and in the polar area what will happen? Wind will, in the way where that surface is cool, there wind will descend. So remember this one also. And till what height is it extends? So like 16 to 80 kilometers at the equator, and at the pole we have the 6 to 8 kilometers. And in this troposphere only, all those maximum phenomena, all those weather phenomena, everything, they occurs in this space only. So see here we have the temperature decrease as we go up the height, like per 1 kilometer temperature decreasing taking place minus 6.5 degree Celsius. Okay, then in this troposphere, okay, even if we go there in the troposphere part also, we are able to survive. So see here, and then in troposphere itself we have the all weather phenomena, all those cyclone, rainfall, lightning, earthquake, lightning, and all those phenomena happening there, all those weather phenomena, they occur in troposphere part only. So remember all these three parts. Okay, and in the troposphere also we have the presence of ozone. See, everyone would have studied that we have the presence of ozone in the stratosphere. Okay, but in that stratosphere is in the stratosphere part, that ozone is a good ozone, and the ozone which we have in the troposphere, that is the bad ozone. So remember that one, that is the bad ozone. Okay, here what is happening? Why it is not a good ozone? Because it is obstructing the path of UV rays. So it is sending back the UV rays that coming from the insolation. But here this bad ozone, this does not play the same role. So that's why in the troposphere part, in the upper troposphere, we have the presence of bad ozone. Okay, okay. Now in this part, we'll also see in this part only, the troposphere part only, we have the jet stream. So jet stream will be like 6 to 12 kilometer height. In that height it will be there. So jet stream is wind, its speed will be like 200 to 350 kilometer per hour. So because of this, and see, we all will study why all those flights, all those aeroplanes, they are not flying in this layer, whereas they are flying in the stratosphere part. Okay, so why? Because see, we have the presence of jet stream, that strong wind that is blowing in this troposphere part. Okay, then also we have one more cloud part, that is known as the cumulonimbus part. Okay, cumulonimbus cloud. See what this cloud? See, when we have the thundering, okay, a huge thundering sound with the lightning. So that particular clouds, so that happens because of the bursting of this cumulonimbus cloud. So that particular cloud is known as the cumulonimbus cloud. So this cumulonimbus cloud also is present in the troposphere part only. Okay, troposphere part only, and this cumulonimbus cloud is present in this troposphere part. And if it bursts, okay, if it bursts, then what will happen? Even that flight part, they will blast. Okay, so they will blast, and you see we have the presence of jet stream also. So that will be obstructing the speed of the flight also. So troposphere part is not considered good for the flying of aeroplane in this area. So because of this reason only, flights are not flying in this troposphere part. Okay, and this cumulonimbus part we will see when we study about the clouds. Okay, they are in the cauliflower shape. They will be like cauliflower shape. Okay, and when they burst, why? See, like in a mountain area recently in Uttarakhand, we had the cloud burst. Okay, so that cloud burst, that is a part of this one, this cumulonimbus cloud. So remember that one. So cumulonimbus is the earthquake. When it bursts, there will be like heavy thunderstorm and lightning. So remember that one. Heavy thundering and lightning. So remember, in the troposphere we have the temperature decrease, life is present, it have the all weather phenomena, then jet stream is flowing in this troposphere part, and because of jet stream only we have La Nina and El Nino. That monsoon seasons in India that we are having, that is because of jet stream only. Okay, then we have the presence of cumulonimbus cloud in this part. So because of all this jet stream and cumulonimbus, this layer is not suitable for the flying of aeroplane. So now we enter the stratosphere. So stratosphere, what happens? Now this is the layers of Earth. Okay, when we have the troposphere, this part, to somewhat like 2 to 5 kilometers, we have the tropopause. This area is the tropopause. Okay, because here what is happening? That temperature, that normal lab set that is occurring the troposphere part, here it is silent. Okay, here neither the temperature will taking nor increasing. Then after that, when we cross this part, so there what will happen? Here again the temperature will start increasing. So when the temperature starts increasing, so it is going in like inversion way. So here we study in the troposphere part, that as we go height, in the heighter part, so what will happen here means temperature will start decreasing. But here in the stratosphere, what happens? Temperature starts increasing. So this you can better understand it with this line part. So see here, now our this line is going like, okay, in tropopause area it is silent. Then again here it starts increasing. Okay, so this particular is known as the temperature inversion. So this is known as the temperature inversion. So the temperature inversion we have in the stratosphere part. So remember that one. Then in the stratosphere part we have the presence of ozone hole. So remember, we have the presence of ozone in the stratosphere part, which block the UV rays reaching the Earth. So we have the presence of ozone in the stratosphere. Okay, and in that, see, if the ozone crosses this stratosphere part, then we have the skin cancer. We might suffer from the skin cancer part. So here in this layer we have the presence of ozone which blocks the UV rays coming down to Earth. And see why this part is chosen for the flying of aeroplane. See here what is happening, all those phenomena, bursting phenomena, jet stream, all those phenomena happens in the troposphere part. Okay, and see as we go height, so temperature also will be increasing, and also the pressure will be increasing. And after that what will happen? There when we goes into space, there will be like vacuum type. There will be no presence of atmosphere, so we will be flying. There will be no presence of gravity. Okay. So here in this stratosphere part, what is happening? There is no such phenomena that which can obstruct the flying of aeroplane. Okay. So because of that only, see as we go up, if you go into mesosphere, then again there we have the changes. So only see we can fly our aeroplane either in the troposphere, but troposphere we are not, it is not possible because of jet stream and the cumulonimbus cloud. So in the when this, just to increase the to maintain the speed, to increase the speed of aeroplane, so we are flying in the stratosphere part. And those, see when it is flying, and if it is domestic flight, so that domestic flight will be flying in this tropopause part. Why? Because see, if this is so, from here they started flying. Okay, so from here they started flying, and it is domestic flight means here they have to come down. So again they have to go like, see, if longer flight means what, they will go up, then they can travel, then they'll descend. But here means it is not possible to suddenly descend the flight. So that's why they fly in the tropopause part. So mostly all those domestic flights, they fly in the tropopause, and all those international flights, they fly in the stratosphere part. So just for your knowledge, remember that aeroplane used to fly in the stratosphere part. Okay, so don't get confused that it will fly in the tropopause parts also. Domestic flies will be flying, but if question comes, so remember that it flies mostly in the stratosphere parts. So all those phenomena are given here. So see here, the troposphere ends with the tropopause. Then as we go up, there is a temperature falling 6.5 degrees Celsius per kilometer. So all those, everything are mentioned in the details. Then this, in the troposphere we have the all weather phenomena like cyclone, rainfall, fog, hailstorm, all these. Then here it is also known as the convective region, because we have the all convection stop at the tropopause. So all those convection stops in the tropopause here. So this convective region. Then see, it is minus 45 degree Celsius at the poles and minus 80 degree Celsius over the equator at the tropopause area. Okay, in the tropopause area we have that temperature. So remember that we saw in the previous slide. So at the tropopause area we have that area that at equator and poles. So greater fall in temperature above equator is because of the greater thickness of troposphere. Okay, then the troposphere is marked by the temperature inversion and turbulence and eddies. So remember that all those phenomena we have the in the troposphere only. So this is all about the troposphere. Then we have the tropopause. So here in this layer it is marked with the constant temperature. Then topest layer is that we know that it is troposphere. Then it acts as a boundary between the troposphere and the stratosphere. So if questions comes, which layer of the earth is known as the boundary between the stratosphere and troposphere, that is tropopause. Okay, now stratosphere. So after that 18 kilometer it will start extending and it ends up to the 50 kilometer from the earth surface. Okay, then here we have the negative lapse rate. Then in the troposphere we have the normal lapse rate. In the stratosphere we have the negative lapse rate. Okay, so that is also known as the temperature inversion. So remember this one, that temperature inversion person. Okay, then that ozone is present in the stratosphere part. So here what is happening, that ultraviolet light splits O2 into the individual oxygen atoms and then atomic oxygen and then combines unbroken O2 to create O3. So remember how O3 is created. Then that ozonosphere. See, in this layer ozone extends like maximum of the ozone will be between the 20 to 30 kilometers. So in the ozonosphere it lies at an altitude between 20 kilometers and remember that mostly 30 kilometers and only some amount will be there in the 55 kilometers from the earth's surface. Okay, and spans the stratosphere and the lower mesosphere. So highest concentration occurs between the 20 kilometer and 30 kilometer. So remember that we have the presence of ozone in the three layers: tropo, strato and meso. So in that what is happening, that maximum amount is in the stratosphere and in that also maximum amount is between the 20 to 30 kilometers. So remember that one. So because of the presence of ozone molecules, the layer is observing the harmful ultraviolet radiation. So this is about the ozonosphere. Then because of there is a formation of O2, then after that we have the formation of O3. So remember all those things. Then in this layer we have the stratospheric ozone depletion is caused by the, if ozone depletion is taking place, so remember it is due to the some chemicals like CFC from the trees or HFC, hydrofluorocarbon, or you can say it as the hydrocarbons, fluorocarbon, that one, then PFC. So all these are responsible for the depletion of ozone. So remember that if C is coming, so mostly all those are responsible for the depletion of ozone. So in that C, stratospheric ozone depletion is caused by the chlorofluorocarbons, bromofluorocarbons and other ozone depleting substances that increase the concentration of the chlorine and bromine radicals. So they are increasing the chlorine and bromine radicals. So because of that we have the ozone depletion. So because of that we have the ozone hole. So this is all about the stratosphere and the ozonosphere. Then third layer we have the mesosphere. So while studying in the starting class, there we saw that meteors See, from the up parts when they have broken, then that smaller parts they change into the asteroids, then like you can say the meteorites, then after it smaller parts it became into meteors. So when the meteors enters in this layer, okay, they burn up in this layer. See, you'll be seeing like a shooting star. Everyone will be saying that shooting star we saw, that it will be like a light type. Okay, so that shooting star is nothing. Okay, that nothing but the burning of meteors in the mesosphere. So that is shooting star nothing but burning of meteors. So remember that one. So that is not a stars, okay, or planets. So shooting star is the burning of meteors. So most of the meteors burns up in this layer. So temperature drops with increasing altitude. So this is, see, this mesosphere is the coldest layer of the Earth. So remember that one. Then see, mesosphere. In this layer, there will be mostly no activity, only that burning will be happen. And why that burning will happen? Because of high friction in this area. So that high friction burns up all those meteorites in this area. And in this layer, remember that we have the presence of one noctilucent cloud. In this layer, we have the burning of meteorites, and also we have the presence of noctilucent cloud. So if questions comes, which cloud is present in the mesosphere, that is a noctilucent cloud. So that noctilucent cloud we'll see in the what is the noctilucent cloud, that we'll see in the later part. Then after that we have the thermosphere. Okay, so in that thermosphere, what is happening? We have the presence of ionosphere in that area. Okay, so in that area, maximum all those satellite, FM radio, all those navigation takes place through the ionosphere area. So remember that FM radios, or you can say radios, satellites, everything, that communications happens due to the presence of ionosphere layer in the atmosphere. Then we have the exosphere, that is the outer layer of the Earth. So in this layer only we have the presence of that hydrogen and helium. They have escaped and they have come this in the outer space. Okay, and in this we have the small traces. So now see, in the mesosphere part, we saw that it is the coldest layer of the Earth. Then we have the meteorites burning in this layer. So in this layer we have the presence of noctilucent cloud. So just below the mesopause. So you see in this area also we have the mesopause. So remember the tropopause, stratopause, mesopause. So mesopause means what? That it will be between the mesosphere and the thermosphere. And stratopause means it will be between the stratosphere and mesosphere. So remember that one. So see, what is known as noctilucent cloud? So just below the mesopause, the air is so cold. Okay, so in the mesosphere, that is the coldest layer. The air is so cold. So even the very scarce water vapor at this altitude can be sublimated. So sublimated is what? That liquid directly changing into the gas. So that's sublimated into the polar mesospheric noctilucent clouds. So they change the polar mesospheric noctilucent clouds. So these are the highest clouds. Okay, and they will be the visible to our naked eyes during the sunset and sunrise. So remember that these clouds will be not studying in this cloud part. Okay, and see, so it is actually present in the mesosphere. So remember only that name, and that is presence, that it has the presence in the mesosphere. Then we have the thermosphere. So here what is happening? Temperature is rising. Then as that height is increasing. Okay, because of that radiation from the sun. Then ionosphere is present. Then in this layer only we have the presence of Karman line. Okay, so we have the we saw that when we cross the 100 kilometer, then we enter into the space. So that 100 kilometer is known as the Karman line. So remember that one. So see, by international convention, this marks the beginning of space where human travelers are considered to be astronauts. Then all those aurora, australis, and borealis. So that all those takes place in the thermosphere. Sorry, aurora australis, aurora australis and borealis that takes part in the exosphere. Exosphere. So don't get confused. That takes part in the exosphere. So in this also we have the rarefied gases molecules. So only we have that escaped gases, that is hydrogen and helium. So the international space station and satellites orbit in this layer. So we have the presence of space station and satellites. And aurora, all those australis and borealis, they are observed in the lower part of this exosphere. Then see exosphere, that is extending like beyond the ionosphere, that 400 km. Then here we have the rarefied, and temperature gradually increases through this layer. Okay. So while studying, don't get confused with this slide. So this slide is a part of exosphere part. So light gases like helium and hydrogen float in this layer only. Okay. And temperature also is increasing because it is nearest part to the sun. So this is all about the layers of atmosphere, a structure of atmosphere. Okay. So now we'll study about the composition of atmosphere. So composition of atmosphere, see here. So remember all this, how much we have the presence, how much amount of particular gases are present in our atmosphere. So this is about the composition of atmosphere. So remember this formula: no AC NH kilometer. Okay. So no means nitrogen. We have, because see, this type of questions might come for arranging in decreasing order or in increasing order, amount of percentage of volume present in the atmosphere. So remember that no AC NH kilometer. So nitrogen, oxygen, then we have the argon, then at the fourth number comes the carbon dioxide, then we have the neon, then helium, then krypton, then methane. So remember this formula. And we have the very less amount of presence of hydrogen. Okay. So remember this formula, that is no AC NH kilometer. The proportion of gases changes in the higher layers of the atmosphere in such a way that oxygen will be almost, so when we go in the higher layers, so there will be oxygen almost to no, like means zero, to negligible. So quantity at the height of 120 kilometer. So similarly, carbon dioxide and water vapor are found only up to the 90 kilometer from the surface of Earth. So this is all about the composition of the atmosphere. So this is all about the structure and composition of the atmosphere. And remember in this structure and composition, in this remember all those particular phenomena. Remember all those particular phenomena that have taken place in that all those layers, because that type questions might be asked, like ozone is ozone, they might give the questions like ozone is present in which layers. So in that way they will give the option of troposphere also, mesosphere also, and stratosphere also. So remember that in all these three layers we have the presence of ozone, but all those good ozones that are maximum present in the stratosphere, and maximum amount of ozone are present in the stratosphere part. So remember that one. So don't get confused with that part. So okay. So now we have finished about the structure and composition of the atmosphere. Now after this we'll start about the heat budget of Earth. So budget means what? Now we'll start the budget of the Earth. Budget means what? Like even if we be in home, or like even you can see in our parliament, there is a proposal of budget. So budget means what? That particular amount of money, how it is to be distributed, how it is to be used. Okay. So in that way we have the heat budget on our Earth's surface also. So heat budget means you can take it as 100%. And how this we have the heat budget? That is because of incoming solar radiation. So that incoming solar radiation is known as the insolation. Remember that the incoming solar radiation is known as the insolation. So now in this part, first we will study about the insolation. Then after it, we'll see all those heat budget parts. and how it is affecting, what are the factors responsible for the affecting all those parts. So everything we'll see. So in the heat budget part, first we have the how we have the budget. See, now for even for the parliament, like if budget means they have to arrange something from there, like from the tax they are getting. So in that way they have the money. Then after they are distributing the budget. So like in that way also we have the, in the same way on the earth we have the insolation. Okay, and remember one thing, that when the sunlight coming to the earth, insolation coming to earth, they are the short wave radiation. Okay, they are a short wave radiation, and when they're hitting the earth, and after that some amount of radiation are reflecting back, they are going in the long wave radiation, and that long wave radiation is known as the terrestrial radiation. That long wave known as the terrestrial radiation. So remember this one also. So see, when that heat is falling on us, that we can take it as like a 100%. So like 100 unit is coming down to earth. So if the 100 units coming down to earth, okay, and if it is hitting the earth, and even if the 4 units are left on the earth, okay, then what will happen? Now after storing, it will be slowly storing those heat of the sun. So what will happen? After a few years, it will become fully heat. Then it will start changing the molten state. So there we would not have. Then there will be no life possible. So if Earth would have been saving, see, in like even in the budget in like parliament or even in the family type, you can see. So like our mothers are saving money. So it is not same here in this part. Okay, it is not same here in the earth part. Here what will happen, if earth will start saving all those energy on its earth surface, then like one day it is saving, out of one day it is saving even 4 unit also, then after that again 4 unit. So all this, after that what will happen, will have the high amount of temperature. So there will be like after that slowly all those due to temperature, so all those they will start melting. So there after that few years it will become, or everything will become in the molten state. So because of that there will be no life possible. So remember one thing, that earth never saves those heat coming from the solar radiation. So remember that one, that how much it is coming, that how much it is influx, that much is the outflux. That means how much it is hitting the earth, that everything going back into the atmosphere side. Okay, so this is about the heat budget. So all these are balance are happening by, see, now only see out of 100 unit, only some amount of heat is coming on the earth surface and they are reflecting back. So that amount they are balanced by the long wave radiation, that is terrestrial radiation. So all those heat budget we'll study here in this class in the later part. So see here, insolation is what? That sunlight coming, incoming solar radiation, sunlight coming to the earth. So that is insolation. So earth surface receives only a part of this radiated energy, that is like 2 units out of this much energy. So why it is receiving 2 units? Because of that, because of our presence of atmosphere layers, there is a loss of all these heats in that layer itself. Then in some layers what is happening, in some layer before reaching the earth surface, in some layers it is reflected back from that particular layer itself. So that everything we'll study in the later part. Okay, now these factors after the distribution of insolation. So what are the factors there? They are affecting. So they are the angle of incidence. Okay, now this due to the tilt, we have that sunlight is falling directly over at the equator. So because of angle of incidence only, and it is rotating on this part only, so because of that only we have that heating of the earth. So that is angle of incidence. Then distance between the earth and sun, that perihelion and aphelion, that you would have studied, that when perihelion, when Earth is nearer to the Sun, that is perihelion. That happens on the 3rd Jan. And when in the aphelion part, what happens? When the Sun is farthest from the Earth. So that happens on the 4th July. So here what happens? Now if Sun will be near, means our Earth will be receiving more amount of sunlight, and if Sun will be farther, means what? Farther means it will be receiving less amount of sunlight. So because of that also that is affecting the temperature distribution. Then we have the transparency atmosphere. Means how? Transparency, what? In the atmosphere there are presence like meteors are coming in the mesosphere part. Then there are presence of some dust particles. So because of that also, that all those parts are reflecting back from their self, and because of that they have the light is taking some other path to come. So because of that also we have the reflection. So that transparency of atmosphere is also the part that is affecting the distribution of insolation. Then we have the sunspot. So sunspot you all would have studied in our starting part. There we studied that in the photosphere part, like sun has a layer, okay? In that we have a photosphere layer. There we have that because of what is happening, because of gravitational field in the outer surface. So what is, because of high gravitational field, all those energy coming to this part, they are reflecting back themselves. That is going away again into the inner part of the sun. So because of that we have the presence of sunspot, that is also known as the dark spot in this part. So that sunspot, what is happening? That is cooling down because heat is not reaching it. So because of cooling down, that is becoming dark. So that is known as the dark spot. So sunspot is also affecting the distribution of insolation because it is blocking the sun rays to come to the Earth's surface. So from there it is going back to the inner part of the sun. So these all everything are it is given in the slide. So the energy received by the Earth's surface in the form of short wave is known as the incoming solar radiation. So the amount of insolation received on the Earth's surface is far less than that is radiated from the sun. So because of a small size of the Earth and its distance from the sun. So that everything we have put up in the slides. So just go home and see. So see here on 3rd Jan we have the perihelion, on the 4th July we have the aphelion. So all these parts, because of that also we have the variation in the insolation. Then also one more part is that is albedo. So albedo is mostly it is incoming solar radiation only. Okay, so that we'll study in the later part. So that albedo is what? That incoming solar radiation when it is coming. So when that reflected amount, like when that it is coming to the surface of Earth, when some amount is reflected back, okay, that reflected back radiation is known as the albedo. So remember this one, the reflected amount of radiation is called as the albedo of the Earth. So the value of albedo will be different according to the surfaces. Different what? At every surface that sun is directly over at the equator part. So there we will have the maximum amount of albedo because it will be reflecting the maximum amount of long wave radiation. So there we have the maximum. Then at the polar area we have the less amount. So that is the value of albedo will be different at the different surfaces of the Earth. Okay. So see here, this both part is the albedo part. See, albedo is given its value like 0 to 1. Okay. If we have that reflecting amount of radiation very less, then it is measured between 0 to 1. Then what is happening? That 1 means if we are taking it as the 100%. Okay. So and 0 means 0%. So like 0%, then 1%, then 2%. Like that we have till the 100%. Okay. So in that this is all part of the albedo. How much it is, that amount of radiation is reflected by. Okay. So here what will happen when you go to the glacier side, snow area. If there is a fresh snow, okay, fresh snow, and if there is a sunlight. So when you go outside near the fresh snow, out of the home. So there, you won't be able to open your eye. Why? Because of the reflection. So fresh snow have the maximum amount of albedo. Remember that. That see, all those amounts are mentioned here. Okay. So remember that something like one part of this one fresh snow. Then we have the other part like in sand side. If you go, we have the maximum amount of albedo. So all those measurements are mentioned here. So study all those measurements. Only some, because fresh snow will have the maximum amount, like see here. Fresh snow we have the 0.40. Old snow we have the 0.40, then fresh snow we have the 0.95. So it is nearer to 1. So it has the maximum albedo. So remember that one. Okay, in this one part is not there in the slide, I think so. So one part there I had in that slide, there is a albedo part. In that we will be seeing that all those maximum for arranging. So that slide I'll say in the after the class. So like water vapor albedo. So all those. So only one slide in water vapor we have clouds, we have those albedos. So remember that one. So now factor influencing insulation. So rotation of the earth, we are receiving only some amount of sun rays on the earth part. Then here remember one note that maximum insolation is received over the subtropical desert. Okay, so remember why? See, because of this only we have the maximum desert. See, everyone is saying that we have the maximum desert in equator area. No, we have the maximum desert in the, like you can say, in the tropical area between the 30-degree side, like 15 to 30-degree type. Okay, because there we have the tropical area. So maximum insolation is received over the subtropical desert. So where the cloudiness is the least. See here what is happening in the equator side. Here we have the like highest amount of heat here we are getting. So here what is happening? Here air is shading. So here air is going up. Okay. Then when the air is going up, it is mixing with the cloud. Then here we have some amount of rain also. So because of that, here we won't have the desert area. So that's why what is happening here, after in this desert area, air is what is there coming down, descending. So there we have the subtropical desert. So remember that one. Okay. So heating and cooling of the atmosphere. The sun is the ultimate source of atmospheric heat energy. Okay. So that can be decided in different ways. So terrestrial radiation is what? That incoming solar radiation that is reflected back. So that reflected back amount of that radiation is the terrestrial radiation. So terrestrial means what? Long wave radiation. Okay. Then conduction means what? How conduction takes place? So conduction means you can take it as like we see when we cook something, or you can take example of pan. Okay. So what will happen? This which is on the full, the part which on the fire part. So that will be first heated. Then after some amount will come here. Then that amount of heat will be transferred to this place. Then again this place. So like transfer of heat will be going on. So that is the conduction. Okay. Then convection is what? That we say that part is rising. Okay. So due to high amount, so this part is rising from here. So that is convection. Then again it is falling down. So that is convection. And advection we'll see in the later part. So advection is what? Like it is hitting the nearby objects without any connection. So that is the advection. That we will see in the later part here. So this is about the terrestrial radiation. So that everything we saw that what is terrestrial radiation. So terrestrial radiation is that long wave radiation which is going back to the space. So that is about the terrestrial radiation. Okay. So before so see here, all objects whether hot or cold, they radiate energy. Okay. So hotter objects they will emit more energy, and the colder object will emit less energy. So the temperature of an object determines the wavelength of the radiation. So the temperature will determine the wavelength. So when Earth surface after being heated by the insolation, it becomes a radiating body. Okay. So that is known as the terrestrial radiation. terrestrial radiation. So remember that one. Then see here. Sorry, this albedo part is here. Okay. So see here that we saw that albedo, which part have the highest albedo. So see here, albedo is measured from the 0 to 1. Okay. So albedo is measured from the 0 to 1. So when it is measured means like it can, that we saw that we can take it as the 0% to 100%. So fresh snow have the maximum amount of albedo. Then we have the old snow. Then we have the in the sand part. So all this they will be the what they will be doing. They will be radiating. They will be reflecting back. They will be reflecting back maximum amount of sun's solar energy. Okay, they will be reflecting back maximum amount of solar energy. So remember in that fresh snow we have this much. Then grass we have less radiation, and forest which are absorbing all those radiations, so they have the less amount of albedo, and which are not absorbing, they are reflecting back, they have the maximum amount of albedo. So remember, so a grass or forest, what they are doing, they are absorbing all those parts of sunlight to do photosynthesis on all those parts. So because of that, they have the less amount of albedo. If it comes for the arranging, so remember a maximum amount we have in the fresh snow, then we have in the old snow, then we have in the sand 20 to 40%. So all those weightage, all those albedo percentage are given in those slides. So see from there. Okay. Then in water vapor, in the water also we have the minimum amount also, and also we have the maximum amount. Okay. So when water has come as rain from the clouds, so here we have the minimum amount, like 5 to 10% only we have the albedo. Why 5 to 10? Because when water will like cool down, so that will be observing the light. Okay. And when it has become warm, and when it has become the water vapor, so water vapor also will be having the 50 to 80% of albedo. So remember this one. So this is all about the albedo percentage. So just go through all those slides and study all those albedo, and you must know to arrange. So important ones like fresh snow, old snow, sand, and you must know about the water vapor, all, and grass forest. All these are important. So they might ask for the arrangement. So remember all this. So this is all about the albedo. Tomorrow we'll see about the advection. Then after it we'll see about leftover part. That main part, that is heat budget. Okay. And tomorrow don't miss the class. Tomorrow we'll see about the pressure belts also. So pressure belts, if you understand the pressure belts, then only you will be able to understand about the winds, all those winds, then all those cyclones, how it is happening in the ocean part, all phenomena happening in the oceans. So all those you will be able to understand if you understand the pressure belts. So tomorrow is the most important class. So tomorrow don't miss the class. So okay. So if anything you want to ask, you can ask from me now. Tomorrow again when we meet back, we'll start studying about the advection. Then after that, we'll see those heat budget part. So any doubt in these parts? Any doubt in these parts? Okay. Okay, no issues. When you go back home, I think so one or two part are like mixed up. So that part I will arrange it and I'll send it to you all. Okay. So just go through that slides and just do the revisions. And in that, while studying, if anything is there, you can ask from me. Okay. So that's all for today. Tomorrow again we meet at the same time and we'll study about the heat budget, pressure belts, all those. Then after it we have the time, means we'll study about the winds. So tomorrow come in that like 5:30. Come at the particular times. Most of are coming like you all are coming by 5:40. So you are a little bit late to the class. So come in the time. So okay, so that's all for today. We'll finish up the class. We'll meet again tomorrow at the same time.